screen, sir.
Yeah. I am just linking YouTube.
Okay, sir.
Give me some time.
Yes, sir, no problem. Yes, sir. Yeah,
Okay.
now I have shared the screen. I hope you can see that, right? Sir, can you see my screen?
Not yet.
Not yet, sir.
Then now you can share.
Now?
Yes, now it's visible.
Yes, sir, it is visible.
Fine. Okay, so thank you very much. So today I would like to just start the session with basics of logistics regression. Then I'll run the program in Jamovi. I hope that is fine, right? Yeah. There are 6 learners, I think. Can any learner just mention, is it okay or something? Because I just wanted to start the basics of logistic regression, because I hope you already have gone through the linear regression, and even in the last session also we have seen that linear regression thing. So it is just an extension for our basic y is equal to mx plus c. Like, so if this is x and if this is y, so either y is equal to f of x or it is mx plus c. And it is a simple linear regression where you are going to deal with only one variable, one independent variable, and so this is dependent variable. So suppose if this is constant and if this is m, a slope. So if you have multiple variables, suppose if we, in the last class we have seen some accident happening with because of 3 aspects. So there are 3 aspects which will be causing these accidents. So maybe rainfall or the distance traveled or some kind of road. So these are the 3 things which have caused accidents. So this is a dependent variable, and so this is independent variable 1, this is independent variable 2, this is independent variable 3. So especially as linear regression will be useful for finding this outcome when these are continuous variables, and so this is also continuous variables. So if we are dealing with only continuous variables, then we can use our linear regression. So that is what the problem that we have run in the last week. But coming to the logistic regression, so if we are not dealing with any continuous variables, or if you are dealing with any categorical variables, under such circumstances we'll be having only either yes or no, or 1 or 2, or positive or negative. So for such conditions we are going to use your logistic regression. So, and logistic regression is a statistical model used for binary classification. So this is used for binary classification tasks. So where the goal is to predict one of the 2 possible outcomes. So this is what the important thing here. We are trying to predict either yes or no, or positive or negative, something. So under such circumstances, we are going to use this logistics regression. So it belongs to family of generalized linear models, GLMs, and it is widely useful in various fields, including machine learning, medicine, finance, social sciences. So now probably if you just take either the case of the patient severity, whether the patient is severe or in critical condition or normal condition. So for such things, we can use this logistic regression. So is the patient is in danger or not? So when the variables are in categorical nature, so in such cases we will not be able to use linear regression. So we are going to use something called logistic regression. Okay, so this is, and especially this is going to be useful to predict the probability of a particular categorical response for a given set of independent variables. Suppose if you see here, like a binary dependent, either you will purchase this or not, either you will accept the proposal or not, whether the patient has got heart issue or not. So in these circumstances, we are going to use this yes or no category. Okay, so either patient is healthy or not, or you are going to purchase this or not. Okay, so for such circumstances, you are going to use your logistics regression. And so there are certain scenarios where we are going to see this one. So this application areas of logistics regression are medical diagnosis, finance, marketing, and credit scoring. So most of the people will be using this logistics regression for credit scoring. Okay, whether we can give the credit for this guy or not. Okay, so because that depends upon the credit worthiness of the person. But similarly, as we are going to deal with accident related or safety related precautions, now we need to see how far the things that we are going to use, the procedures or policies that we are going to use will be feasible for us. Okay, that is going to be this one. Suppose now if you see there are different independent variables or predictors. So maybe time, health related, or some kind of other things. So this is going to be dependent variable. So the dependent variable, whether the how far this is impacted or influenced by either independent variable 1, independent variable 2, and independent variable 3. So this is the thing that we are going to see. So here either probability is usually, if this is going to be 0.5, we try to just make this something like that. If we are getting an outcome more less than 0.5, so then probably that will go to this category. When we are getting a calculation greater than 0.5, so that will come to one category. So this is what the basic assumption that we are going to use. And this follows a function which is called as f of z is equal to 1 divided by 1 plus e minus e power minus z. So there is nothing to panic by seeing this one. It is just an extension to the linear regression. Okay, so this is going to be the probability of occurrence of or non-occurrence of a particular event. Okay, so probably this is going to be some theoretical part. Now, if you see this one, so linear regression when it is going to be used, and logistic regression when we are going to use. So linear regression will be used for basic regression problems. Okay, and logistics regression will be used for classification problem. Okay, so here you can see a linear regression x-axis and y-axis. So though there are lot of variables here, you can see either a continuous line or some kind of line or something will be like this. But coming to logistics regression, either your output is going to be either 0 or your output is going to be 1. Okay, so it usually takes 0.5 as a benchmark in many of the cases. Okay, so we can change that also, but if we tentatively what we feel is if it is less than 0. If our calculation comes to be less than this one, it is going to be considered as 0. If your calculation is coming to be more than 0.5, we'll consider it to be equal to 1. Okay, so this is usually going to be either yes, and this is going to be usually either no. Okay, so once we see certain problems, I'll show how to calculate that 1 divided by 1 plus e power minus z in Excel as well as in Jamovi. Okay, now this is mostly useful for continuous variable. So this is mostly useful for categorical variable. So this is more sensitive towards outliers. When there is an outlier, so probably it straight away just tries to extend this value, or it can drag the value also. But coming to logistics regression, it is very less sensitive to outliers. I hope you know what do you mean by an outlier. Okay, so there are 7 to 8 learners. Can anyone just tell what do you mean by a simple outlier?
Extreme values, extremely high.
Any extremely high value or any extremely low value. Okay, suppose if you are trying, there are 8 students, 8 learners here. So maybe the package level, suppose if I just wanted to take 5 people package levels. Okay, so salary levels. So first person salary is maybe 60,000. Second person salary is going to be 80,000. Third person salary 55,000. Fourth person salary 1 lakh rupees. Okay, so 100,000. So fifth person salary is, suppose if it is 8 lakhs. Okay, so then this is going to be simply an outlier. Or the 8% salary, maybe it is just assume it is 15,000. So in that case, this is also going to be an outlier. Any extreme high value or any extreme low value is called as outlier, and linear regression is easily impacted because of this outlier. But logistics regression will not do, because either our outcome is going to be either 1 or 0. So in that case, it is less sensitive towards that one. Okay, and assumes the total distribution is normally distributed. I hope you have already seen like what is normal distribution, where it will have a proper mean and standard deviation is equal to 1. And this logistics regression will not assume the data to be distributed the errors will be distributed in normal. And this is applicable for forecasting and effect analysis. And so this is applicable for ideal classification and identification, whether this is going to be either threat or no threat. Okay, and so this assumes homoscedasticity. Okay, constant variance of errors. And so this will not assume homoscedasticity, that is no constant variances. There might be changes in that, and it might assume some cases like heteroscedasticity also will be dealt in these cases. And linear regression will be used to fit a best line, so best regression line. But coming to logistic regression, it is going to be an S curve for classifying whether male or female, or yes or no, something like that, or diseased or no disease, either no harm or harmful. So this uses ordinary least squares method, but this uses MLE, so maximum likelihood method. So that is what very important. So this means like maximum likelihood means, so I can categorize a person into either this category or this category with the features which is mapping with other group of people. I try to check whether this person is matching with this category or this category or this category. Based on that, I'll tell that whether this person can belong to this category or the opposite category or the other category. So if I just try to check like the features of a person and maybe mustache or something, so probably I can call that person as male. If there is no mustache and the behavior is somewhat girl, so probably that new person can be called as a girl. So this is what you are going to classify by depending upon the characteristics of this new person and comparing with a group or set of people. So this is what linear regression and logistic regression. And coming to the logistics regression application, so independent variables or predictor variables. So maybe this is x1, and so this is x2, and this is x3. So now we are going to see a simple example like age of a person, whether age of a person impacts the heart health, or gender of a person impacts the heart health, or smoking impacts the heart health. So probably either if these three are impacting, so then I can call it as a person has got some heart related issue. If it is not properly impacting, I can tell that the person is safe and there is no heart related issues like that. So this is what we are going to see. Okay, and dependent variable or the criterion, I'll check whether this person heart has got any disease or no disease. So if 0 means there is no disease, 1 means there is a disease. So this is what my classification. So logistics regression will be usually useful for the classification problems. Okay, and what is the classification? So suppose I'll just take age of a person. As I said, age is my first variable. So this is my first variable, x1 variable. So there is a person who has got 22 years. There is a person who has got 25 years. There is a person whose age is 18, 45, 12, something like that. Similarly, gender. First person is female, second person is female, third person male, fourth person male, and fifth person female, like that. And next thing is next person, the third variable. So this is going to be x2 variable, and coming to my x3 variable. So smoking status. So this person is non-smoker. So second person is a smoker, third person is a smoker, fourth person is a smoker, fifth person is a smoker. So here by seeing that, I'll check that, okay, so if age is less and male, female, so there might be disease, heart disease, either yes or no. So here this person has got a heart disease in spite of a non-smoking, okay? And second person is a smoker, obviously we'll expect some kind of health problems that is there. And third person is a smoker, and fortunately this person doesn't have any heart related issues. 4% no smoker, and this also will be validated. There is no problem. Okay, so fifth person is a smoker. In spite of that, there is no heart disease. So this is only 3 to 4 data, and if you just take a big data set of 30, 40, 100 or something, then we can fit a best logistics regression model. Okay. So next, this is what the basic differences between linear regression and logistic regression. So coming to the linear regression, so this dependent variable is dependent on all independent variables, and these usually the slopes, either B1, B2, B3, B4, up to so on, are called as regression coefficients, or you can simply call it as slopes. Okay, so these are called as slopes. Okay, and coming to the logistics regression, this is a linear regression which will be whose value lies in between minus infinity to infinity. So this is what linear regression. But coming to the logistics regression, it is talking about the probability between 0 and 1. Okay, either you have disease or you don't have disease. So probably by seeing the features of a sample, we try to classify that person into either this category or this category. So that is what the reason here. And equation for logistic regression is, as I already mentioned, is f of z is equal to 1 by 1 plus e power minus z. So where f of z, so usually if you see, this is going to be this z. If you try to observe this z, so this is represented as b1x1 plus b2x2 plus b3x3 plus up to so on bkxk plus a. So this is what the basic linear regression that we have seen. So that is what I have mentioned here. So y cap or y predicted is equal to, so lot of observations and whose slopes multiplication, and this total is going to be this thing. So 1 plus e power minus z. So this z is completely that y cap prediction. So that is what you are going to see here. And hence probability of y is equal to 1. So getting some issue is given by probability of y equal to 1 such that x1, x2 up to so on condition probability is going to be 1 divided by 1 plus e power minus b1 x1, b2 x2 plus b3 x3. So this total content will be in the minus thing. Okay. So that is the only difference that you are going to see in linear regression and logistic regression. So linear regression will be useful for a continuous predicting a continuous variable and whose value lies in between minus infinity to plus infinity. It can go up to any extent. As I already mentioned, so it will be easily impacted because of outliers. But coming to this logistics regression, either value is going to be 0 or 1. It will be in between minus infinity to plus infinity, but all values fall into either these two categories only. And coming to our linear regression, so y cap is equal to b1x1 plus b2x2 plus b3x3 plus up to so on bkxk plus a constant. Okay, but this total equation will be kept with a minus sign, and so e power minus sign, so 1 plus 1 divided by. So this is what logistics regression output. Is that clear? Is that fine, or anyone has got any doubts? So this is just a theoretical explanation, like why we have to use logistic regression and when we have to use logistic regression. If it is done, then we can go with some data set and practical application. Is that fine for all the learners here? I hope you are able to understand. So, or you are feeling that straight away I've just taken some power something, because most of you are from BTech background. I hope this is not going to be a huge issue for you, right? Can I have a
Yes.
Yeah.
Yes,
Fine.
yes.
Okay, so Sameerji, thank you for the response. So now you see, so theory concept, definitely it will make some impact. So probability of disease or probability of having some issue is equal to, so I have just mentioned B1x1, B2x2, but instead of that B1x1, I'm just mentioning B1 into age. Instead of x1, I have mentioned as age. So B2 into gender, B3 into smoking status. Okay, so which is going to be a most impacting variable. Okay, maybe sometimes either this can impact or this can impact or this can impact, or all the three can impact, or these two impact, something like that. But our duty is to find out that one. So probability of disease. So this is how usually probability will be checked, and I'll just try to show that solution here. Okay, so that is fine. I'll take a simple problem. Okay, so then it is somewhat better for you. Yeah. So here, I hope you can see my Excel screen, right? So where I've got some 30 observations. There are 30 observations. And first observation, so traffic volume is 25,000 vehicles. And the second column is rain, whether rain is yes or no. Okay, so 0 means there is no rain, and 1 means there is rain. And speed violations. So how many vehicles have violated speed? So 15 vehicles have violated that some kind of speed maximum limit. Okay, and in accident happened, there is no accident happened. Okay, so in this case, this is what the first data set I'm going to deal with Jamovi today. So in this case, if you see, so these are the things which are there. So first observation is, that was first day's observation. So the 25,000 vehicles have been passed in a road, and there is no rain, and there is no speed. There is 15 vehicles got speed violation, and there is no accident. Coming to the second observation, so traffic volume is 30,000, and rain is, again, there is no rain, but speed violations have been done by 22 vehicles, and it is 1. So 1 signifies there is a accident happened in that day. Okay, so either 1 accident or 2 accidents, some accidents happened on that day. So third observation, if you see, 28,000 vehicles, there is no rain, and speed violation only 18 vehicles, there is no accident happened. And coming to the fourth observation, 35,000 and 1 rain means there is rain on that day, and speed violation also happened, and accident is 1. So this is what the data. I hope you are able to understand the data, right? So data is, I've taken 3 parameters. So the first parameter is traffic volume, second parameter is rain, third parameter is violation, and accident happen. So what is going to be when you are going to see accident? So if you just try to highlight this particular data, so and if I just go to a condition formatting, and I just try to highlight when it is going to be equal to 1. Okay, so I'm just trying to highlight. So when I just try to highlight here, so there is accident here, so there are 2 accident here, accident. So when I have got some accident here, so you can see like what exactly happened. Is rain is causing that one? In this case, it is not. So here, the traffic volume, whether huge volume is causing that one, maybe yes or no. Okay. So here speed violations 22 has happened. So once you observe these things, like so here, if I just try to check like the speed violations thing. So I've got total 30 and average is 23. So average is 23. And if I just try to identify, I'm trying to just highlight the variables which have got 22. Okay, so because my average is 23, and when I see this one, when there is more than 23, there is an accident. So in this case, though there is less than 22, there was some accident. So in this case, though there is more than 25, there is no accident. But apart from that, so here violation vehicles are more than 22, and accident happened. So more than 22 accident happened, more than 22 accident happened, more than 22 accident happened. Here more than 22, but accident did not happen. So this is what the data. And if I just try to compare this one, and I try to compare this one, when I have to highlight the data, if it is equal to 1, okay, and I just try to highlight in some other color, so green fell, and I click OK. Okay, so 1 minute. So I will try to highlight this one. So when there is more than 1, and white to green field. Okay, so why it does not happen? How to clear all the rules, select data. So then I'll try to highlight when, if it is 1 minute. So when in this case my data is equal to 1, I have to highlight that in certain green color. Okay, I'll see whether is rain causing. Yes, in these two instances, rain has caused. In this instant also, rain has caused. So this instant, rain has caused. So here also rain caused, but rain caused accident. Here, rain did not cause accident. So here, if I just see, there are certain times where rain has caused accident, and certain instances rain did not cause accident. So if I just try to take the other variable, okay, and it is showing average as 31. So I'll try to highlight this also in some other color. So if it is greater than 31, highlight that in yellow color. Okay, so this is what. Now I'm saying, so this in this context, accident happened, but it is not 31. So in these two has cost. So these two has cost. So these two has cost. Now I might be having a doubt whether which is the variable which is impacting this completely, and what is going to happen when my traffic volume. So I'm just assuming if my traffic volume is 32. So if my traffic is 32, so I'm just writing traffic is 32, and my rain. So rain is happening. So if rain is happening, I'm just calling it as S. Okay, so I'll just make it as no. So if rain doesn't happen, that means it is 0. And my speed violations. So speed violations case, I'm making it as some 28. So if this happens, what is going to be the probability of having accident? Okay. So the people who are present over here. So whether my question is okay for you? I hope you. Is there anyone who did not understand my question? If you don't understand, I'll try to repeat or explain the question once again. Now, I'm trying to predict. So my intention is to predict whether the accident will happen or not. Accident will happen or not when my traffic is 32,000 and there is no rain and speed violations are 28. So this is what my question. Is that clear?
Yes.
Okay. So
Yes.
yeah, so thank you. So now I'm just trying to open my Jamovi to take this data set. Okay, so now I hope you understood the data set, and I'm trying to take this data, like what exactly the data. So 13th April, and so logic accident prediction. So I'm taking this data. So this is what my accident prediction data. Here I can see I've got observation, first observation as the number of observations. So 30 data set, traffic volume 25, rain is equal to 0, 1 something, and violation happened and accident happened. And I see, so whatever I've written, so probably, so this is what the data which I've got. Now to run that regression, so in last class we have seen linear regression. Now I'm running the logistic regression. So for that one, I hope you have already seen what is this variables data thing and analysis here. So in this, I've got correlation matrix, partial correlation, and linear regression. And we are talking about logistic regression and two outcome. So two outcome, either accident will happen or not. So this is what I need to find out. So for that, I'm just taking this one. And so out of all these things, so my accident is my dependent variable. Okay. Either traffic is impacting or rain is impacting or speed violations are impacting. So this is what I need to check. Okay. For that, I'm just taking my accident into my dependent variable. So accident, if 1 is equal to yes, if 0 means there is no accident. So this is what my assumption. And I'm just taking all these three variables into my covariates. Okay, so covariates means, so these are my continuous variables which are impacting my accident related thing. Okay, so here if you see, so this model has got some value here. And if you see the model fit levels, so reference level is, it has been taken as 0, and model fit, usually there is something called as McFadden's R square. So if McFadden's R square is 0.6, usually that is considered to be very good fit. Okay, so this is what one thing that we need to observe here. And so this AAC is Akaki information criteria. So for the people who are into in-depth research, so that is required. But for now, There is no requirement. And if you just uncheck this, probably will not have this one. And for model checking, probably you are going to see this pseudo R square, this is McFadden's R square. So this is what required for us. Okay. And so default, these two will be there, but there is not that requirement for the people who are starting some kind of researches. Okay. And model fit. So here you can see this is what the overall predicted value, and you can see here intercept is one thing. So intercept estimate, and I hope you know the basic linear regression, the same thing that you are going to see here. So whatever you are going to get here, so you have to just copy, and maybe I can just copy all, and I'll go to my regression thing. So maybe I can just paste here also. So paste here also. So this is what my regression. So since it has disturbed and there is no clarity, I'm just taking that to a word output. So that is what I'm just taking here. So this is what the output. I hope this is the output, right? So 1 minute. 0.842. 1.66. No, this is not the one. Logic. I'll try to open that particular output so that you can explain that. Okay, so logic explanation. Yeah, so this is what the overall output. I hope you can see the output. I've just copy pasted here. So what it does is, so this is what the model that I'm going to build now. So this is called as odds ratio, and you can see that so logarithm of p by 1 minus p. So in linear regression, we have made a continuous variable, but here there are certain categorical variables like yes or no something. So this is 13.362. So that is 13.36 that I have mentioned here, and minus 1.406. So that is 1.41 into traffic. So minus 0.49. So into rain. So this is minus 0.49 into rain, and 1.308 into speed violation. So that is 1.31 into violations. So this is what my basic expectation of the equation. Okay. And so whatever I've just taken here, so this will be taken as p is equal to 1 divided by 1 plus e power minus z. So I hope you remember this value. So this total equation 13.36 minus 1.41 into traffic minus 0.49 into rain plus 1.31 into violation is called as my equation z. Okay. So that is logit result. So that is logistic regression is usually referred to as logit, L-O-G-I-T. This is what my Z value. Okay. And if I see these p values here, so I hope you can see this one. So for intercept, p value is 0.166. For traffic volume, my p value is 0.069. For my rain, the predicted value, so the p value is 0.755, and speed violations is 0.042. Out of all these variables, which is most impacting or most significant, or which are the variables which are significant here in this model fit? So in this model fit, like which are the variables which are impacting my accident? Is intercept impacting, or traffic impacting, or rain impacting, or speed violations is impacting? Any idea? If you don't have idea, you can just tell me. I'll try to explain. No idea?
No idea, sir.
Fine, no problem. So here we have to see the p values. So out of all these p values, is there any particular heading which has got less than 0.05? Is there anything which is less than 0.05? So this is what we need to check out of all these things. Okay. So this is the 0.166, which is more than this one. So it is not an impacting variable. Okay. So this is 0.069, which is slightly higher than 0.05. So this is also not impacting. So this is 0.755, which is way high or more than 0.05. This is also not impacting. So this is 0.042. So definitely this is an impacting variable, okay? All these are certain impactors, but which is the most significant variable? So speed violations. So this is what I need to focus. Is that clear? This is how we'll be able to identify out of 10 variables, which is most impacting, okay? Suppose if you simply take any particular IPL team is not winning, maybe continuously 3 to 4 matches. So maybe batting failure is one reason, bowling failure is one reason, toss winning or losing is one reason, or fielding might be one reason, or motivation of the people might be one reason. Out of all these things, definitely one or two will be more significantly impacting. So that is what you need to find out. Okay. So this is definitely causing a huge impact on the accidents. And maybe I can consider traffic volume also next impacting, though it is not less than 0.05, but it is somewhat nearer to that one. So, okay, but rain is not going to be significantly impacting. So, rain is not a problem. So, there might be some kind of explanation that when there is a rain, usually, maybe I'm just asking you, like if it is rain, usually whether you will be driving, suppose if you are driving either two-wheeler or four-wheeler, when it is raining, whether you will drive fast or slow. It's just a normal question.
No.
Slow.
Definitely.
Yeah, this is causing people to go slow, and because of that, there is no problem. Okay, so even if it is whenever it is raining, probably people are to be somewhat taking more care. So because of that, though it is raining, sometimes it is not happening. But most of the accidents are happening because of this speed violations. As you are working in some company, Maruti company or some other company, so you'll see like industrial accidents. So why a particular industrial accident is happening? Is it because of no training, or is it because of low training, or is it because of age of the machine, more age, more usage, or is there any non-cleanliness maintenance in the production floor? So you'll see many reasons, or power fluctuations are causing accident. So maybe all this will be causing accidents, or some of these will be causing accident. You need to identify which is more significant among those things. So this is how the logistics regression will work. Is that clear? And if I just try to take this particular value to my Excel output, so I think I've got some Excel output here. I'll take you to that Excel output. So, no, shift explanation. Okay, so this is what my basic table, which I've taken here. So I'll just try to copy this table. So what exactly I have to take? So this is what my output here. I'm just taking this output. I'm just copying this output here and taking this to your value. Okay, so this I'm pasting here. So now you can see I've just pasted this value here. Now, as per my explanation, I said, so this is what my equation. Okay, I think this is not that value. This is 0.049. So this is other output post. I'm sorry, I'll take the correct output here. Okay, either these or that, not an issue. Okay. Okay, so I've taken my value here. So traffic volume, rain, accident. So as I mentioned, usually that predicted equation is going to be, so P is equal to, I'll take this also. This is what the thing which I require here to explain this one. And so this is my Y prediction. So Y prediction is equal to, so this is 15.314 constant plus, so all are minuses only here. So I'll take traffic volume as minus 1.719 into traffic minus 0.459 into rain plus 1.660 into speed violation. So speed violation. Okay, so this is what my basic equation. Now what I have to do is, I know my constant value is 15.314. I'm writing this constant as 15.314 here, and my traffic. So traffic coordinate, so this is, I'll take this one. So my traffic coordination, so this is intercept. So traffic value is minus 1.719 and my rain value. So rain value is minus 0.459 and speed violation. So speed violation is 1.660. Okay. So as I already told, suppose, and what is my expectation? So I just wanted to check. So this is what my expectation. So what will happen when there is, so this is what I'm trying to predict here. So my traffic is, so 32. Suppose my traffic is 32 here. I'm just writing 32 here. And there is no rain. If there is no rain, it should be treated as 0. If there is rain, it should be treated as 1. And speed violation limits are 28. Okay, so this is 28. So as per this equation, I have to multiply these values here. Okay, so this is multiplying product I'm writing here. So product is equal to this multiplied by this. Okay, so I'll just try to drag that to the last. Okay, now here this is going to be, as there is a constant, you have to multiply by 1. I'm just writing as it is here. And here I need to find out sum. So this is what overall sum here. So this is equal to sum of my intercept plus traffic coefficient plus rain coefficient plus speed variable. Okay, this is done. So as I said here, this probability I have to find out, and probability either here it is going to be, my probability is going to be either it might be 0 or 1. If it is 0, what it means? So you have to just tell if it is 0, what is the meaning of that one? So my probability, if the probability is 0,
Accident will not happen.
so there is no accident. Okay. If it is 1, so then accident will happen. So this is what I'm trying to predict. Okay. So now as I already got these values here, so now I have to just find out 1 divided by 1 plus e power minus z. Okay. So now I have calculated z value as 6.786. Okay. So now I need to find out this minus value. So this is z actually. I have to just find out minus z. After that, I'll just try to find out e power minus z. After that, I'll try to find out 1 plus e power minus z. Next step, I'll try to find out 1 divided by 1 plus e power minus z. So this is what my total probability value. So this probability value, either it can come some value. So straight away, this will not come as 0 and 1. But here I need to specify one condition, as I already mentioned. So if the value is less than 0.5, I will assume this to be 0. Okay, even if I get 0.43, I have to assume it to be 0. Okay, so this is what the cutoff rate I have to mention. And if it is more than 0.5, I have to make it as 1. Okay, that means accident will happen. So this is what my expectation. Okay, so whether accident will happen or not. So for that, I need to calculate all these things. As of now, I got only z value. I have to multiply with a minus 1 so that I'll get a negative z. Then I have to apply exponential of I have to get the value of exponential of negative z. Then I have to add this to 1. So then I have to just add, I have to divide 1 with this value so that I'll get a final value. Whatever the value that I'll be getting, I have to classify it to either 0 or 1 depending upon the value. So if it is more than 0.5, I'll classify it as this one. If it is less than 0.5, I'll classify it as 0. So, okay, so if it is 0, I'll just mention it is no accident. No accident can be predicted. And if it is 1, I can predict that accident can happen. So it can result in accident. So this is what my answer or so my values was. Okay. So now I'm just again going to my regular Excel here. So this is equal to, so minus 1 multiplied by this particular value. So this gives me my negative z. Okay. So this next is equal to exponential of my negative z. Okay. So either you can just do like that or you can find out like this. So this is 0.001129. So here this is equal to 1 plus the final above value. So this is 1.001129. So here this should be equal to 1 divided by this particular value. Okay. So here, if in this case, I got this as 0.998872. So definitely it is more than 0.1, 0.5. So there are more chances for it to happen an accident. Okay, because you can see the speed violation limit is 28. In major of the cases, we have seen this as major impacting variable, and if it is more than 22, 28, more than 22, sure, the chances of accident happening is more. So this is what my explanation here. So here final output. So final output. So I'm just making condition if the value which is located here is less than 0.5, make it 0, otherwise make it 1. Okay, so this is what my condition, and it is 1 because as this value is more than 0.5, it is taken. And final verdict or outcome. So what is going to be the outcome? So here, if this is equal to 1, then accident will happen. If it's equal to 1, so just write accident happens. Otherwise, mention no accident. No accident can be predicted. Okay. So this is what. So in this case, accident happens because I felt that, so this is going to happen like that. Okay. Because this is 1. So is that clear? By taking this table, we have created this value because as I said, so this is equal to probability is equal to odds ratio 1 divided by 1 plus e power minus z. So logic value. Logic value is this one. So why predicted is I've just taken only these values. So I've just taken only these values as this is going to be 1.15.314. I've just mentioned 15.314 here. So second value is minus 1.719. So this is going to be minus 1.7919 into traffic. Next value is minus 0.459. So I just mentioned minus 0.459 and rain. And the last one is speed violation. So speed violation. So this is going to be most impacted variable. So this is plus 1.660. And definitely it increases the rate of accidents. So rate of accidents will be increased because of this one, because these two are positive rated. So this rain is decreasing, maybe surprisingly it is decreasing. And even traffic volume, if there is more traffic volume, so some people will be trying to slow down the vehicles. So slow down is happening either because of this and because of this, and accidents are happening only because of speed violations. If there is no proper control on the speed, people are not able to control the vehicle and they are going to hit that one. Okay. So this is what the observation. Is that clear or anyone has got any doubt? If I can
Yes,
get, yeah. So now I'll just try to show the same thing in one more value for the same thing. I'm just copying my present output here. So I'm just taking my present output to some place. Okay, so this is what the output which I've got here. So case 1. Okay, suppose instead of these things, instead of traffic 32, rain 0 and 28 speed, what I'm going to do is I'm going to try to change. So this I'm deleting now. If not this one, so this I have to. Okay, I think there is no need to do it. So here instead of 32, 0, 28, I will try to just make some difference because now I am a bit in a feeling that even if there is a rain, there might not be any difference like this. Okay, and as major differentiating factor is speed is the one thing. So can you just give any one of you can give a number less than 20? So that I'll make it as speed violation. Any number less than 20. Okay, can I assume it to be 18? I'll try to see what happens if this is 18. Okay, so when it has become 18, because as I have not changed this one, so it has taken this value, sum has become minus 9.814 and this negative of z is going to be 9.814, and e power minus z is 18,287, and 1 plus e power z is 18,288.19. 1 by this value is 5.47 into minus 5, and final output is 0, and it has automatically changed to no action can be predicted. Is that clear? Is that fine, or anyone has got doubt in what now I did? So because I'm strongly feeling that only this is impacting. So only this particular value is impacting. So I try to just check like what exactly can be done, and I'm trying to just place only the speed violations. So speed violations is causing, I try to just reduce this number to 18. So now what I do is, so this is the second output. So anyone has got any doubt? Or is that fine? Any doubt, or is that fine? If I can get a reply, probably I feel that, so whatever I'm trying to convey, that understood to all of you, or at least some of you. Or if anyone has got any specific doubt, I'll try to explain once again. So my concentration is, so only this is impacting. So because this is what 0. Less than 0.05 and something. So probably this also can impact. Okay, so second impact I can see from this one. So what I try to do is, so I'll just try to make some change in traffic volume now. So though my speed violation have decreased, and in this traffic, now it is 32, what I do is, I'll just make this as maybe somewhat higher number, maybe 56, though, which is not available in the data. I'll try to see what has happened. So even if traffic is mostly increasing, that is not changing, and only this speed violation is impacting. Is that fine, people?
Yes, sir. Actually, if 18 number of speed violation is there,
Yeah.
so there is no chances of accident.
Yeah, this is what, according to this prediction, because you can see that the value is very less. According to this prediction, the model which we have fitted, so it feels that there is no accident can be predicted. So no accident can be predicted. Suppose if I just make this as 22, I feel there might be some chances. Even for 22 also, there is no problem. So if I just make it as 26, so 26 also not happening, 27 or 28. Okay, so in that circumstances, okay, so here I have just made, so one more thing. So one more good observation is here. So as traffic volume is increasing, so those speed violations are there, it is nullifying that effect. Okay, so here earlier it was 32, because of that we got 1. Okay, so this traffic volume, as it is a negatively impacting that variable, so it is nullifying the speed violation also. Out of 56,000, if you are there are only 28 vehicles which are deviating the speed violations, the chances of accident happening is somewhat less. So let me just try with some other number, 48. I'll just feel like what happens. So as the number of vehicles are maximum here, okay, so because this 1.719 is more than 1.660, because of that you will be able to see the maximum differentiating factor is this one. And next differentiating factor is coming to be the traffic only. Okay, suppose in this time, if rain happens, we'll see what is going to happen. Even in this case, rain going to happen, there is no problem. Okay, so that means, so this is going to be quite impacting variable. Okay, so first impacting is happening with the speed vehicles, and traffic is the second impacting variable. So that is the reason why, though it is 0.088, it is nullifying some effect which is happening for this one. Is that clear? Is that fine, or any other doubt? Because now if we just try to make this as 34, so sure the chances will increase. So even if you just make this 48 or something, I don't think we are going to get something. Okay, so there is, as I said, nullifying effect is more with traffic when compared to speed. So in this case, I think we have to just make this. So then obviously it will go. So the first impacting variable is this, and second impacting variable is this. As these two are oppositely related, negatively correlated, so there might be, so this sort of things are happening. So this is how we are going to check your output, which you got in your Jamovi. Is that fine? Is that fine, or not getting into your head? Can I have a response from any one of the learners? So definitely, this is slightly technical, but if it is it fine, or do you want me to explain with the same example or another example?
This is fine, but seems more technical. So
Yeah,
it's,
that's what. Fine, no issue. So that's why. So if you are able to understand the basics, no problem. I'll try to take one more example so that you will become somewhat comfortable. Fine.
fine, fine, fine.
Fine, fine. So here straight away I have taken everything numbers. Okay, so here one is S, zero is something like that. Suppose by any chance, if you got some kind of data which is not into straight away like this, okay? Since we have seen all these things, I'm just closing this one. Suppose let me take one more data like this. So hospital data set something. So here you can see there is some kind of data. What is this one? I think I can write something, right? Okay, so there is some kind of data here. So case ID and arrival rate. So here there is something called as arrival rate. So it is a data set of almost 99 patients. So 99 cases. So 99 cases and arrival per hour. In the first case, we have got 14 patients per hour. So second case, treatment time. So 22 minutes time, 49 minutes time, 49 minutes time. So there are different types of different minutes which have been taken for our treatment. So next is severity. The stage in which the patient has got into our hospital. So low severity, medium severity, high severity, something like that. Okay, and outcome. So outcome is 0 and 1. So here 0 means the patient is safe. Okay, and 1 is critical. So though how many patients have come, and out of those people, how much time it is going to happen, and what is the condition in which the patient has been got into our hospital. Finally, after doing this basic surgery, is he safe or is he critical? Okay, so this is what some kind of hospital data set. So similar kind of data set can be created for your company's position. Okay, so company, you are taking some training data. So training, how you're giving the training and how much time the training has been given, and how many vehicles are coming for repair or some kind of floor shop. Okay, so shop floor or something. So in that case, what is going to be the criticality of the vehicle? Is it critical or no? Not a problem. Okay, so 0 means the vehicle is good to go, and 1 means there is some kind of problem with the vehicle and we need to check that vehicle once again or second something. Okay, so this is what the data set. Now we need to fit a model to check this outcome. Like what is the variable which is impacting? Is it arrival rate or treatment time or severity, or sometimes all the three put together is happening? So that is what our objective. Is that clear? Now here you will see the actual impact of this logistic regression here, because it is a number, arrival rate, it is a number, treatment time, and here it is a categorical variable, low, medium, high. So I'm not sure how many of you are thorough with either SPSS or the Excel part. So probably here you need to code the variables. Okay, so you need to code the variables into certain thing. So here, if I just take, just copying this here to other sheet, I'm just creating one more sheet here, and I'm just trying to make how many things are there. So I've just created a table here. Okay, so here if I just open that one, I can see there are 3 categories. High severity is might be high, severity might be low, severity might be medium. Okay, if I just try to check only high, so how many are there? So there are I just try to check, like, so there are totally 17 people have come to our hospital in a severe condition, so high severity condition. Suppose if I just try to check like low severity, so how many people have come? So if I just take low severity people, out of 99, some 46 are in low severity people, and you can see major of the people, so 0, 0, 0, 0, that means they are safe, okay, because of severity. So first thing. Okay, and I'll try to check like the last medium severity. So in medium severity, I can see how many people are there. So totally, I've got 36. So 36. So 36 people are low severe. So medium severity. 36 medium severities and 17 high severities and 46 low severities. Okay. So if I just try to check like what is, I'm just taking this one. And here, how many are critical and how many are safe? So 0 means safe, right? So I'm just trying to count how many are there. So I've got totally 67 patients are safe here. So safe are 67. And obviously, if I just 99 minus 67 is it is 32. So 32 people are critical. Okay. Now I need to find out like what is causing them criticality. Okay. Is it because of the number of patients flow in the hospital? Is it because of arrival rate or is it because of treatment time? If it is taking more time, can I assume it as criticality or not? Or if it is it due to because of severity or something? Okay. So this is what the basic data is. That is everyone okay with the data? Now I need to find out. So if patient outcome has become critical, logistics regression, is that because of either one of these things or two of these things or all the three of these things are causing? Which one is making maximum problem? Okay, so which one is making the maximum problem? So here also we'll try to find out like what exactly we are going to see. So here also we'll be just trying to fit a logistics regression model, as sir has asked me to take logistics regression. Now we'll try to fit a model for this. Okay, so for that what you have to do is first you have to code and decode these things. Okay, so what you can do is by any chance have you come across coding and decoding in any other class? Sir, madam, is there any person? I think only one madam remaining as sirs only. So by any chance, you know how to code, recode this one, how to code low, medium, high, something like that in any other session or class? No. Okay, so as there is no response, I think there is no such things has happened. Okay, so now low. I'm coding low as 1. I'm coding medium as 2. I'm coding high as 3. Okay, so these are the things that I would like to make. Because though logistics regression is something, if I want to run a model in Jamovi, it will not take this value straight away for predicting this outcome. For predicting outcome, I should make all the variables into my numeric variable only. Okay. Otherwise, I'll not be able to check that one. So hospital data is already here. I think we'll be able to show that one. So now here I'll just take so capital low, so capital L, so capital LOW, and capital medium and capital height. Okay. So now I'm just trying to change only this data here. Okay. So this data, or I can change this data also. As I want to make this, I want to give these codes for my data. So low will be coded as Z1 and this will be coded as this one. Okay. So or I can just take my Jamovi itself. So, but you remember this coding part, what I have mentioned. So I'm just taking this one. So this is hospital data 99, hospital data set 99. So this is the name of the file. So I'm just taking my Jamovi file for working. Okay, so I got this thing here. So now I'm just opening that one. I hope all the students or all the learners are okay with the opening of this thing. Okay. So Jamovi, I'm taking 99 hospital data copy. So when I just click that one, it has taken these values. Okay. So now if you see here, case ID is 1, arrival rate is 1, treatment is 1, severity has got continuous, the total theoretical categorical variables and outcome is 1. So So now what I have to do is I have to change these variables. Okay, I have to just rename these. I have to give code for this one. So for that, what we have to do is, so if you just go to data here, okay, I hope anyhow the session is recorded. The session will be recorded and the recording will be given to you. So how to transform this low, medium, high? Because I said, if I just try to run my analysis here, so if I just take my logistics regression to outcome, so here my dependent variable is whether the patient is safe or not. So this is what I can take. So if I just take arrival rate here as a covariate, it takes because it is a categorical, sorry, it is a numerical variable. Okay. So, and if I just take severity, if I take treatment time, so it will take this also, and it has taken this value also. If I just take severity and click here, you can see this scale is blinking. So what it means, I'm not able to move this severity to my covariates. Okay, why? Maybe I can move it to factors here. So factor will be done. My severity has been taken into factors, but not into this thing. Okay. So now if you see this one, low to high is causing a p-value. So this is what I just wanted to tell you, because now if I just make this severity as a factor, okay, so it is causing huge impact. Okay, so low high is causing less than 0.001, and medium to high also it is 0.002. So these two are causing, you can see this thing. But suppose if I want to check like severity also embed severity also into this one, I cannot do this as this is a categorical variable, low, high, medium. I cannot include this into my covariate. So for that, I need to transform the variable. So that is what I'm trying to tell that to you. Okay, so for that, you have to just go to data and you have to click transform here. Okay, so learners, this is a request, and if you are not able to follow at any point of time, you can ask me so that I'll try to repeat the step once again. And I believe all of you have Jamovi in your laptops. You can do along with me. Suppose if you are seriously interested to check how to do transform these things. So here what I'm doing is I'm just clicking transform. It will ask like what has to be transformed. So if I just try to check these left values, it will ask like, so my case ID, am I changing this one? No, I'm just going to right check. Am I changing anything related to arrival rate? As this is already a numeric variable, integer variable is here. So I'm not touching that one. So am I doing anything in treatment as it is also already an integer variable? I'm changing, I'm going to that value. Or you can change this to continuous also, no problem, because though it is a continuous variable, as integers are present, it will not have any impact. So coming to severity, so here it is nominal and it is not integer, it is text. I need to change this value. I cannot simply change it to integer. If I change it to integer, it will become completely zero. So it should be text and I should know what exactly is that value referring to. So when I just initially created severity, I'll just show once again. So I'll just click here. I have placed my cursor on severity and I am going to click transform. So once I click transform, Jamovi automatically creates a particular variable here and it is going to be completely copy of that one. So low, low, medium, 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 medium. So it is complete. Severity 2 is a complete mirror image or copy of this one. So once that copy is done, I need to use this using transform. I have to click this one and there is run and create a new transform. So I have to create a new transform here. I'm clicking this value. So once I click, it automatically takes a value which is called as transform one. I'm taking a new transform here and I'm clicking this add recode condition. So here I have to just give my condition here. So this is equal to, so this double equal to, I have just mentioned like low. I already mentioned low, so that has to be given in double quotations. Low should be coded as 1. Okay. People, I hope you are able to follow. You can ask me if you have any doubts. And I've given first condition. I have to give second condition. So again, click add recondition. So here this is equal to give double is equal to and double quotes. So medium. So medium, I wanted to make it as 2. So somebody might be getting it out like why I should give low as 1 and medium as 2 and high as 3. I would like to reverse low as 3, medium as 2, high as 1. That also can be done. You will see that also. You will be able to see that also. Okay. So here the third condition, if you know confidently that there are only three cases or three categories, high, medium, low, definitely you can give as else category here. So if you can just simply tell that, so I can give else 3. So that is one option. But it is always a better practice to add a new recode condition for double is equal to open that one and high. So even if a small spelling mistake or something will make an error, we'll see whether we'll get that error or I can simply take off that one. So once I click that one, I think there is no error. And you can see there is a severity and severity on the top of that severity, you can see a small red dot. Okay. That red dot is related to this dot here. Okay. So this red dot is shown here. Suppose if I have one more variable which I have to transform. So for that, if I just use, it will show some other color and that variable also will be shown in some other color. So this red color shows for transformation 1, which I've used for severity. So now I'll just go back to my original data. And if I just try to regress that one, okay, so regress, logistics regression and outcome I have taken here. So now my outcome is this, already I know that one. And arrival rate, treatment time and severity. I'm moving all the three here. So now you can see all the three have moved to this one and severity also it has been taken and it has shown a minus, so less than 0.001 value. Is that clear? Is that fine, guys? Or anyone has got any doubt? So this is the second example, and in this I just used some kind of transformation. So how a variable has been transformed or how a variable should be transformed. Okay, and I performed same as usual logistics regression. And if you want to see any descriptor, so here you can mention, you can see that the model estimated using sample size of 99. Suppose if you want to see any descriptives for that one. Okay, so I'll just try to show what is descriptive. Arrival rate, treatment time, and outcome, this one. So outcome is going to be simply 0. Okay, so I'll just try to take this here. You can see how many sample I have taken, 99, missing are 0. Mean arrival rate. So minimum arrival is 8, maximum arrival is 30, and mean arrival is 19.3, median is 19, and standard deviation is 6.47. And coming to treatment time. So treatment time is 45.2 is average, mean, and median is 47. So accurate value. And because this can be like mean values will be impacted with the outliers, but median value will not impact with because of that one. And standard deviation is 17.1, and the minimum value in the treatment time is 15 and maximum 75 minutes. Okay, and critical outcome, anyhow, we know there are only two outcomes, either 0 and 1. Standard deviation is 0.470 and mean is 0.323. Okay, so this is how you can see the descriptors. But as of now, I am not interested in seeing the descriptors. But here I can see this R square for this one. So I'll just check that one. So McFadden's R square is 0.002. So probably it is not a good fit, but so this is what the total value. So this McFadden's R square, so many people will tell that it should be around 0.4 or something. If it is 0.00 something, it is not going to be good fit, but this is how a randomly generated data set. So this is how we can take that one. So if you want to perform the same thing like earlier, we have, yeah, any doubt? No, some person has spoken, like, is there any doubt?
Sir, what is the range of this McFadden R square?
So most of the people feel that 0.4 to 0.6 is going to be.
Yes, sir. What is the range of this McFadden R square?
So that's what. So many people. So range can be anything because it is going to be, because here we can see 0.00. So also it is a continuous variable, and so it is going to be some kind of percentages. If I see percentage here, it is going to be 0.2 percentage. So it is going to be somewhat very less. But usually 40 to 60%, that is 0.4 to 0.6, is considered to be good. Is that clear, sir? It is a continuous variable, a percentage, so 0.00, so anything can happen. But usually that should be, if you want to claim a model to be perfectly fit
Okay.
or very good, so 0.4 to 0.6 is expected usually. Is that fine?
So it should be
Yeah, if it is
between
less,
0.04 to 0.06.
yeah, so this is going to be very good fit. For good fit, people expect that value to be like that.
If it is more than 0.6,
So as far as
it's
as far as I have learned, it shows some kind of overfitting.
if it is somewhere between 0.6 to 0.8, then what
So that's what.
is
Yeah, as far as I know, it is going to be some kind of overfitting
to
in
be
this model.
means uh, as you
P-values are not significant.
Yeah, p-value is significant, especially this p-value is 0. Sorry for this
no,
one.
it is more than points.
Okay, so fine. So this is something, and I'm talking about model fit is this one. So 0.0259. Okay, it is not 0.002. So this is this value. Okay, I was seeing some other thing. Okay, so where I've used only two variables. So this is the thing, sir. Fine. P-value is significant for intercept as well as severity. I was seeing some other output which is not the actual one.
Sir, can we use the dummy variable here?
Sir, actually, I have used the transformation variable. So it is almost equivalent to that, right? I have transformed that variable like that from 0 and 1.
Okay.
So this is what the significant, and so this is the outcome. Okay, and coming to the R square of McFadden. So most of the people feel that for 0.4 to 0.6 is better, and in this case it is 0.259. So somewhat okay, not a perfect good fit, but it's okay. Is that fine? And is that fine, or anyone has got any doubt? Once we see the explanation for this one, so then we can go to the inferential statistics of impacting a helmet rule. So before helmet, what is going to be the severity and number of accidents, and after helmet, what is going to be the number of accidents or something. Okay, so can I just explain this, or you want me to explain that thing? So I'll just try to copy this, and I'm going for my output, and we'll just try to show as I've shown in that Excel. Okay, so here I'm making this. Okay, so this is one. I hope you can see my Excel screen, right? I hope Excel screen is visible or not. Because now, so the probability is, so whatever the probability which I have taken is, so 1 divided by 1 plus e power minus z. Okay, e power minus z. So this is what we need to show. And so that so this minus z, or that equation of z, is equal to the values which we have got. So here I can just take my intercept. It is minus 5.8597. Okay, so this is my intercept. And coming to the arrival rate. So arrival rate is 0.0389. And treatment time, so I'm making TT, so treatment time 0.0182. And last one is severity. So severity is causing to be 1.9262. Okay, so here, as I said, suppose if the number of the arrival rate, so suppose if arrival rate is maybe I can assume that arrival rate to be, so average value. So if I just see this transformation, so average value is arrival at 19.3 and 45. So I'll make it as maybe 24 arrival rate, and the time for this is maybe 54 hours. And severity, I've got three kinds of severities. Okay, so the severity, as I can show, that low is equal to 1, and medium is equal to 2, and high is equal to 3. So these are the three things that I've assumed. So now I'll assume severity to be 1. Okay, so for the first case, so maybe for the case 1, I'm assuming severity to be 1. Okay, so my equation of equation of my logistic regression is y predicted, or z, is equal to, so I will make it as z only. So z is equal to, so it is minus 5.8597 plus 0.0389 into arrival rate. So arrival rate plus 0.0182 into treatment time plus 1.926 into severity. Okay, so this is what my equation. So now I need to just fit a perfect logistics regression equation with this data. So I'm just making, as usual, even in the last case also just mentioned product here. So this is equal to whatever data is there, you can just mention that. So this is equal to this multiplied by this. And so this is equal to this multiplied by this. So this is equal to this multiplied by this. Okay. Now I'm assuming to be low, case 1 low. So I'm just making case 1 low. That's why I've taken here as 1. Okay. Maybe next thought I'll try to change that one. So this is what my sum. So for finding that sum, I'm just using the sum of all these things. Okay. So once I get this, as I already told, this is sum and minus z. So minus z is equal to, I'll just make it as negative z. Z is equal to minus 1 multiplied by what exactly the value which we have got. Okay. So next, e power minus z. So it is e power minus z. So for e power minus z, so this is equal to exponential of this particular value, because I've already applied my negative value here. So next, 1 plus e power z. So e power minus z. So this is equal to 1 plus this particular value. Okay, so 1 divided by 1 plus e power minus z. So e power minus z. So this is equal to 1 divided by this particular value. So this is 0.11. In the last thing also I've mentioned, if this value is less than 0.5, I'll try to make it as 0. If this value is more than 0.5, I'll make it as 0, or I'll make it as 1. So as this is this value, I'll just make the output or probability. So probability as, so is equal to, if this value is less than 0.5, we'll make it as 0. Otherwise, I'll make it as 1. Okay. And outcome is mentioned here. So I'm just mentioning that outcome. So if this value is equal to 0, then the patient is safe. Okay, so that is what I have mentioned. If patient is safe, and else it is critical. So this is what the initial thing that we have mentioned. Okay, so now the arrival rate is more than what they expected. Treatment time is also more than average. But as severity is low, the patient is got some kind of set. Suppose if severity is 3, I'll see what exactly is going to happen. So if severity is 3, so probably he's going to be in a critical condition. So what about this thing? Okay. And if criticality, if a severity is maybe medium, so then also not a problem. So the people who are who are having some high severity, automatically they are going to be in a critical condition. So this is how we are going to plan this logistics regression. Is that clear? I have shown 1, 2, 3, and especially severity is causing the major impact or major damage in terms of outcome. And if it becomes 3, automatically the outcome is going to be critical, and probability of getting issue is more. So if it is 2, the probability, if you see here, so this is 0.477. It's almost equal to 0.5. Suppose if either in this case, if it is coming to be 75 hours, okay, maybe in that case it has crossed 0.5, and otherwise it is less than 0.5. So maybe if it is maybe 65, so even in 65 also it is more than that one. So treatment time, so first impacting is this severity, next impacting is this one. So this is how we'll be categorizing or classifying the people into less or more. Is that fine? So this is how you have to create an equation and how to interpret that. And so this equation will be created with the help of Jama output. That's all, nothing more than that. Okay. So I'm saving this, and if some of you are okay, I'll move to that inferential statistics, like before implementing the helmet rule. So what was the how many errors are happening, and how many accidents are happening, and how many people got injured, something. After implementing that helmet rule, what is the change in the number of health issues or problems and accidents happen, and how much that helmet is impacting. So that is what my next thing. Can I just go to that, or anyone has got any doubts here? Any reply, please? I'll be sharing some more problems also for you for your practice for transformation as well as logistic fitting logistic regression, so that it is going to be quite easy for you. I'll share 3 to 4 problems of for in different models so that you can practice at your end. Is it okay? Okay, so now I'm just going for my the last one. So already these things have been solved. So I'm just moving to the last part for today. So now you can see a t-test data. So paired t-test or something. Okay, so t-test data or something. So before helmet rule, they have seen something like how many people got injured and how many people got something. So these are the people who got injured before the rule of helmet, or how many injuries have been happening. So after, we can see there are certain issues, so certain things. Okay, so this is what the last topic for today, so which is going to be some kind of inferential statistics, like if we implement a particular rule, so how that is going to impact the overall accident related or some kind of issue forecasting. Okay, so if it is okay, I'll just take my Jamovi thing to show that one. Okay, so now I've just taken this Jamovi to prove is that helmet rule is significantly impacting or not. Okay, so if you just go to this thing, like t-test. So t-test is here. So I'm just going for a paired t-test, because before and after I'm checking the same road or some kind of issues. So how many people got injured? So I'm just taking that one. either this is helmet rule or some kind of so something can like a CC camera. So CC camera, so camera surveillance has taken place. So because of that, what is the number of the number of accidents got reduced. Okay. So now you can see like I have to just open a data set here. So I'm just opening my data set. Okay, so where exactly that how to take the data. So I'm just browsing here and so t-test pay. So I'll just open that t-test data here and I'm closing this unwanted thing. Okay, so here, so before and after. So here what you have to do is you have to just go for a paired sample t-test. This is a paired sample t-test. And so what are the pairs? So 10 months data has been checked and I'm just taking that to paired. So if I just take this one, this is showing that 0.0. So p-value is significantly impacting. Okay. So usually what happens is we'll just mention this measure 1 is equal to or hypothesis. Okay. And in terms of hypothesis, you can define like a null hypothesis first. And so in my null hypothesis tells that there is no significant impact of my of this camera surveillance. Either surveillance is there or not, it is not impacting anything. So this is what the first thing is. But alternate hypothesis is one which tells that so there is an impact, it is not equal to. Or I can just mention measure 1 is greater than measure 2. I'm just feeling that the accidents earlier was more and now it is less. Okay, so earlier accidents are more and now I'm taking less. Now I can witness less number of accidents. You can see that here there is a note which has been mentioned here for right hand side as an output. So hash alternative is measure 1 is greater than measure 2. That means there is a decrease in my accidents after having some surveillance. Okay, so as you are working in some company, so where there might be some kind of accidents happens. Okay, suppose if there is a fire alarm or if there is some kind of fire extinguisher or some kind of smoke detector. So after the implementation of that new policy or after including that new fire extinguisher or fire alarm or smoke detector, I can see that there is a significant reduction in the number of casualties or the number of accidents have happened. Okay, suppose earlier as there was no any fire alarm or smoke detector, so the loss was more. But later it has been proved that once you include this fire alarm or this thing like smoke detector, the chances of people escaping from that is somewhat good. So this is what the disaster forecasting thing also. So maybe next, if time is permits, after completion of this, I'll show one earthquake related data set. Like we will be, so there, the prediction of loss has been made. Okay, it's completely into regression related thing. Okay, so this is how we are going to see. Suppose if you want to define oppositely, so this is what not usually correct. Okay, so measure 1 minus measure 2 is less than 0, which is not correct ideally. So which is this is what I need to just mention for that one. So if I just take that one, this is how I can say. Suppose if you want to see some descriptives also for that one. So what is the average value, average number of accidents before and average number of accidents after? So I'll just take these two here. Okay, so you can see this is what the basic descriptives of that one. So before the number of actions happening with this was the total number of, so total is not here. I can just add the total also. I think the total is not here. So usually I'll be getting the total. Okay, you can see some box plots, bar plots, histograms, so many things like whatever the data that you want to show, you can show that one. So here total like what has happened. So this is what happened in the density plot and bar plot something. Well, these are some basic descriptors and I hope you have already gone through this one. So minimum number of actions happening was before it is 120 and after it is 95. Maximum number of actions happened before was 160, after it was 115. So standard deviation earlier was 12.3, after it was 6.38. And median accident is 143 before and after it is just 106. And mean accidents, earlier it was 142, now it has become 105. So there is a significant difference in the means. So as tutors will check like hypothesis testing, like what exactly is going to happen. So is there any significant impact or not? So definitely there is a significant impact in this one. And so this is what p value that I can show here. Okay, so is that clear, learners? So after implementing a certain rule or certain remedy of measure of reducing accidents, I can see a significant reduction in the accidents, not only in terms of means as well as median and standard deviation also got reduced, minimum decreased, maximum decreased, and the significance is also it is less than 0.001. So this is what a simple paid t-test that you can do with Jamovi. Is that fine? Is that fine, or anyone has got any doubt? This is a very simple application of the hypothesis testing here. So initially you will be just defining something. Uh, I'm not getting answer. Like I don't understand what is the meaning of that.
No, it's fine, sir. Only
Okay,
thing is
so
that some of things are technical. We have to again go back to recording and refer that.
definitely.
Else, yeah, else it is fine, and it has given us insights. Means how the small data is useful and can be used for the predictive analysis. So that part is useful. Some of the things which was technical means we got the idea of the basics, but to do the again to run it in Jamovi or in Excel, we have to refer the recordings.
Definitely, definitely. So suppose if this is what a simple data, I'll just try to check like how this total hypothesis testing will be done. So normally you'll be just mentioning null hypothesis. So null hypothesis is there is no change in accidents before and after of implementation of that one. So accidents before and after. Okay, so before and after. So this is what basic expectation that will be. And coming to the alternative hypothesis, there is a significant difference, or I can mention there is a significant reduction in the number of accidents. So reduction in number of accidents. So in number of accidents after implementation of that system. So accidents after implementation of the system. So for that, so here alternative hypothesis is mu1. So that is earlier before is greater than mu2. So here this is mu1 is less than or equal to mu2, or I can mention it is mu1 is equal to mu2. Okay. So that is average number of accidents before and after are same. Average number of accidents before was more when compared to after. So this is what my claim. So ideally, I hope you have already come across something called as a null hypothesis, alternative hypothesis. So null hypothesis is true, null hypothesis is false. When we just go with correct what is alpha and what is beta. I hope since you already know the things, so now we need to just find out the difference. So usually if you just go by manual method, you are going to just find out the deviation. So 120 minus 95, this may be 25. So this is maybe again 35. So this is 30. So there is a reduction here. So again 30. So this is 45. So this is 36, I think, right? So 36. And here it is 145. So you'll be just finding all these things. So usually your t-test is going to be d1 bar divided by square root of s by square root of root n something. So this is how you will be doing the t-test, right? So normal manual calculation. So what is this value? So if you just take this value and find out what exactly in your table value, will get something. So instead of doing that one, you can just straight away use Jamovi. Or even in Excel, you can just use very comfortably your data, and your data will just make that Excel very comfortably. So if it is a 2 sample pair t set, so 2 sample for pair t test, you can just go to that one and you can just select your range 1 here. So before and your range 2 here. So this is what second one. And here you will just mention hypothesis mean. Usually that will be considered as 0. And if you just try to check the output here, so you will get some value. Okay, so at 0.05. So there is a significant difference. And if you see the p-value, it is 4.3 into 10 power minus 8, which is quite significant that this is impacting. So there is a huge impact of pre and flow. Okay, so this is how you can just take either equal to 0 or greater than 0, something like that. So this is Excel, and that's what I've shown. And whatever the values that we have got here, 16.6 something. So the same thing we might have got here also, 16.7, or degree of freedom is 9. So degree of freedom is 9. So whatever we have got here, 16.7 something and 9. So that is what we can see here also, 16.79 something. So average, mean, so mean is 143. So you can see that this variable is mean before and after 141.9, 105. So here that has been mentioned 142, 105. And variance observation and standard deviation. So here standard deviation is given, variance has not been given. If you want to see that variance, that also can be included. And so this is the thing, sir. So whatever you can see in Excel, it is just extended version of that one. So here I have to calculate all these things. Instead of that, you can straight away take that values. Okay, so this also I'll try to share with you. And as I told, since there is 15 more minutes, I'll just try to show one more earthquake, only the data, not a detailed explanation, because I feel it is going to be almost too much for many people. So here I can just show some kind of earthquake data risk. So exactly the data is present. Okay, so the earthquake data is not here. Fine. So in that case, okay, I'll just try to show what exact. 1 minute, I think it is in my downloads. Downloads also it is not there. Yeah, it is not there. Fine. So let me just explain this output. I'll be sharing this earthquake data also. So here you can see a lot of damages happen. So magnitude, this one. So damage happened. So how much damage has been happened? If we just try to check some kind of exploratives for this one. So you see, these are the all continuous variables here. You can just take this one. So magnitude is like the minimum is 4 and maximum is 9.16. So depth 2.26 and 649. So and distance is 2.32 and 449. And damage in millions. So there are certain cases where there is no damage. There are certain cases where 209 millions have got damaged. So there is disaster forecast. Like how much is going to be our disaster? Like if it happens again. Suppose in this case, suppose if you can see that if magnitude is 5 and depth is some 100 and distance from the kilometer is from 2.2 to 449, assume it is 300. So what is the tentative damage that can happen to me, or that can happen to this particular thing? So this is what the damage here. And you can see here, so now I'm just asking a simple question to all. Okay, so here I'll just try to show one variable here. You need to identify, okay, so which are the variables which are impacting. Yeah, okay, so fine. This is the thing, this is the overall values that I have taken here. Okay, so borders, all borders. Okay, and control 1, remove the space. Okay, so now here you can see the descriptors. Where is the, yeah, so this is what my p-value. Okay, so my p-value is located here. Now, can I just ask like what exactly, what are variables which are impacting here? So we can see that damage happens. So this is what, by seeing which variable, we'll be telling that this is impacting and this is not impacting. This is the table which I've got. So now please tell me, like, how can I just tell that, like this variable is impacting, this variable is not impacting? There are many reasons, there are many ways, but what is the basic way that I can tell that this variable is impacting the overall damage. Any guess? So I've just shown the same thing here. So yeah, so now I've just explained. So blue thing I've mentioned, it is impacting. Why did I tell like that?
Because the speed valuation is less than 0.05.
Very nice. So thank you, sir. So now just tell me out of these variables, which values are impacting or which variable is impacting my damage. My damage is caused because of either intercept or magnitude or depth or distance to city. Which value is quite impacting? So
I think
you
depth.
depth. Okay, so depth is impacting because p-value is less than, sorry, depth is impacting because p-value is less than 0.01. So here also you can see that depth is impacting because, so here also you can see that, so this is impacting because it is less than 0.05. Okay, this is more than 0.05. This is also more than 0.05. This is also more than 0.05. So these three are not significantly impacting. So you can see in this case, again, this measure and intercept, it is less than 0.01, 05, so it is impacting. This is less than 0.05, it is impacting. This is less than 0.05, it is impacting. So this is not a significant impacting variable. Okay, significant impacting variable. And in addition to that, you can see something in the earlier table. So in this table, okay, so here you see, so okay, here there is no estimate, but here I have just created something called, which is called as a confidence interval, lower and upper. In lower and upper, you can see, so this is a negative variable, and this is also a negative variable. If these two are negative, negative and negative, so this is an impacting variable. Okay. So second case, 16.15 and 19.81. So positive and positive. If these two are positive, this is also an impacting variable. Third, negative variable minus 0.12 minus 0.973. So this is a negative variable and this is also a negative variable. So this is also an impacting variable. You can see the last thing. So this is a negative variable and so this is a positive variable. Okay. Similarly, you can see something called as positive variable and negative variable. So in that case, this will not have an impact, significant impact on the final outcome. So damage millions. So damage is not huge impacted because of this distance to city. So distance to city is not impacting. Okay. So this is how we'll be able to identify this p. So p value is the one significant. In addition to that, if you can see that, so lower and upper confidence intervals. Okay. So if you just see your Jamovi output, so here in model building or model coefficient, so there is something called confidence interval. So this confidence interval, I'm clicking, because of that, I'm getting this one here. And now you can see, if I check this one, if I just click this one, I'll be getting lower and upper here. So whenever I get something negative, negative, it is impacting. Negative, positive, positive, it is impacting. Negative, negative, impacting. Negative, positive, not impacting. Similarly, positive, negative also not impacting. The lower and upper should be only on one side, either positive side or negative side. So then it is going to be a significant impact variable. And another thing is, you might be getting something as t value here. So t is minus 4.4, 19.37, 15.3, and 1.29. So we'll try to calculate that in your, I think this can be done with the regression also in Excel also. It will show both t critical and t significant. So t critical value and t table value. So based on that, so t statistics. So there are two things: t statistic and t critical. So t critical is the book value, and t statistics is our calculated value. So this is what our calculated values, which are very high for the first variable and second variable, third variable. Okay, I'll just take this one. So for the first, second, third variables, so I'll show this one here. So 1 minute. Okay, so if I just take this one. Okay, so yeah, so this t minus 1 4.4, 19.37, and 15.39. So these three are very high when compared to T critical. Okay, so T table value is going to be very less, and these three are high. Because of that, we have rejected the null hypothesis, and here it is not so high. It is 1.29. So T statistic is less than your T critical in this case. Because of that only, it is not a significant value. Okay, and you can see these things. So your intercept is going to be negatively impacting your damage, and so this is going to be increasing your damage. So this is depth in kilometers is negatively impacting your damage, and so this is also positively impacting. So these are the things that we can see from this tables. Okay, so I'll be sharing all these outputs so as it is. Otherwise, if you want to just delete, you can just delete these things. Now you'll be able to relate these markings also if you see once I share these things to you. Okay, so now I'm done. If you have any doubts, you can ask me. Otherwise, it was very nice and many of you have interacted. So I'm happy for that one. If you have any doubts, you can ask me. Otherwise, you can call for the day. And sir, anything else, sir, from your side? Roy, sir, anything from your side?
Yes, sir. Hello.
Yes, sir. Yes, sir. Please, sir. Anything?
Huh.
I'm done with the sessions, and I'll share some
Yeah,
examples.
yeah,
Yes.
I understand. I understand. Actually, whatever the presentation you have made,
Yes, sir.
that is very much vital for the two purpose. One is to identify the predictors
Yes, sir.
for the safety behavior.
Yes, sir.
Number two is to make the preventive measures
Yes, sir.
for the accident
Yes.
purpose particularly.
Yes, sir.
And finally, you have nicely presented the before and after the hypothesis testing, which is very much important for them because they are the safety officers and they are the trainers.
Oh,
So, so they are basically engaged with this time, that to what extent their training is effective. So what will be the model for studying the training effectiveness? So that can be elicited through your lecture related to the regression analysis. I hope that my students have understood your lecture, and if it is possible for you, like Professor Rama Madam, that is giving some assignment to them, so they will try to uh, solve the problem, and your function will be to evaluate. So if
definitely,
it is
definitely, sir.
possible, then that will help the student.
Yes, sir.
Another thing that is missing, that is the data visualization.
Okay.
Yeah, you have given many things, but the data visualization, that is missing. So
Okay.
I hope uh, they can do it because we have trained them different type of data visualization,
Okay.
and I think they will be able. So, and particularly when we are using Jamovi, and they are the data visualization and some of the important parameters like what is the function of AIC and why AIC is important, why are we calculating AIC, that is not very clear from this presentation. Otherwise, this is very good one. I think they can understand.
Fine, sir. Thank you, sir. And I'll be sharing some workout sheets where the data visualization is also there because Rama madam told she has already covered the data visualization topic. That's why I did not touch that one, sir.
No, related to the logistic regression, they
Okay.
have understood the non-logistic, that is a simple linear regression. They
Okay.
have understood the data visualization, but in case of the logistic regression,
Okay.
where we are following the S curve,
Right, sir.
so what will be the data visualization in that context? So
Okay,
if
okay.
we can train them, that would be nice.
Sure, sir. I'll share a simple workout for that also. And as you
Sure.
requested for some questions, and I'll give data sets and some work so that learners can practice hands-on. And if they have any
Correct.
doubts at any point of time, they can get back to me or you or Farah ma'am, sir.
Sure, sure, sure. So students, I think you have understood what sir is trying to tell you. So what is your impression? If you think you are satisfied, then it is okay. And if you have any question, you can ask. Akash, Anand, Pritish, Shamir, Jogesh, any question you have?
No, sir,
Okay,
no
sir,
question.
since there is no question.
Yeah.
Jogesh, are you telling something?
No, no, sir, actually, there is no question, sir. And it was very insightful.
Okay.
Thank you, sir.
Okay, thank you. Sir, on behalf of RPRIT, I'm privileged to thank you for your very nice presentation, and you have given your valuable time for us. So thank you, sir.
You're most welcome, sir. So thanks a lot for sharing my insights with all the esteemed learners because many people have explained their answers and they are very responsive. So thanks a lot for being part of this one, sir. Thank you, sir.
Thank you, sir.
And thanks a lot to all participants. So thanks a lot.
Okay. Best wishes to all of you. Good night.
Thank you, sir.
Good night, sir. Thank you. Thanks a lot
Yes,
to all.
Thank you, sir.
Yes, sir. Now you can close.
Yes, sir. Okay. Okay, sir. Thank you, sir. Bye, sir. Good night, sir.
Good night.